Hello to everyone. In this lesson, we will learn how to plot the graph of any function. Okay, the following analytical strategy can help us in plotting the graph of any function. And look at the steps now. The first one, domain and range of a function. Second, intercepts. Third, asymptotes. Four, type of a function. Five, find f prime x. It means first derivative, and the second derivative is f prime prime x. Sixth one, increasing decreasing intervals, extreme points. Seven, concavity and inflection points. Eight, sketch the graph. Okay, if we follow these steps, we can sketch the graph of any function. Look at one example now. Plot the graph of the given function. F of x is equal to minus 2 over x minus 5. The first one, we need to find domain and range of a function. To find the domain of rational function, we just equalize, not we just write like x minus 5 denominator is not equal to 0. Yes, from that x is not equal to 5. It means domain will be all real numbers except the number 5. And to find the range of the given function, we just express x in terms of y. It means that we leave x alone. And here we can write like x minus 5 is equal to minus 2 over y. We can change these two terms. Okay, then x will be equal to minus 2 over y plus 5. After that, we need to exchange x and y. Y will be equal to minus 2 over x plus 5. And by looking to this equation, we can find our range of the initial function. It means that if we find the domain of this equation, it will be the range of this equation. And the domain here is all real numbers except number 0. It means that the range of our function is all real numbers except number 0. Okay, the first step is done. Second one, we need to find intercepts. To find x-intercepts, we need to equalize y to 0, yes? And here, we know that our range is all real numbers except 0. From that, we can equalize here to 0. It means we don't have x-intercept. Our graph of a function is not intersecting x-axis. And to find y-intercept, we need to equalize x to 0. And here, y will be equal to minus 2 over 0 minus 5. It means that here we have 2 over 5. And this will be our y-intercept. Okay, next, asymptotes. We need to find asymptotes. To find the vertical asymptote, we just said that if we have a rational function, we just equalize denominator to 0 and x and solve this, yes? X is equal to 5, and this will be our vertical asymptote. Okay, and to find a horizontal asymptote, we need to take the limit of the given function when x approaches to infinity, and this will be equal to, if we put instead of x infinity, it will be minus 2 divided by infinity. And we know that the limit of this one will be 0. It means y is equal to 0 will be our horizontal asymptote. And after that, let's check if let's check the oblique asymptote. To find the oblique asymptote, we just take the limit of the given function dividing by xs when x approaches to infinity. And what will be here? It means that minus 2 divided by x squared minus 5x. And if we put instead of x infinitive, here will be minus 2 divided by infinitive. And the limit will be 0. What does it mean? By this, we can find the k, yes? And we know the general form of the oblique asymptote is y is equal to kx plus b, and if k will be equal to 0, it means that we don't have oblique asymptote, okay? And here we just found vertical asymptote and the horizontal asymptote. Okay, next step, 4. Type of a function, even, odd, or neither. To check this, we just put instead of x minus x, yes? It means we need to find f of minus x. And here, if we put instead of x minus x, here we have minus 6 minus 5. And this expression is not equal to our initial expression. It means this function is can't be even function. And after that, if we take out of the bracket minus, sign minus, and here will be, okay, let's write like this, minus 2 divided by minus x plus 5, yes? We just take out of the bracket sign minus in denominator. After that, if we simplify minus by minus, here will be 2 divided by x plus 5. And this expression was also not equal to our initial expression. It means it can be odd. From that, our function is neither, yes? Neither even nor odd. Okay, why we check this? Because if we have even function, our graph will be symmetric to the line. For example, like this. For example, if we draw a parabola, this parabola is symmetrical to this line, yes? And it means that this function is even function. And if we have odd function, for example, like this is odd function. Odd function will be symmetric to the point, okay? We can say that this function is symmetric to the point. And with checking the type of a function, we can imagine that our function here, this function, graph of this function will not be symmetrical, okay? Next, fifth one, we need to find the derivative, the first derivative and the second derivative. Okay, let's find the first derivative, f prime x. We can use here quotient rule. It means minus 2 derivative multiplied by x minus 5 minus 2 multiplied by x minus 5 derivative divided by x minus 5 squared. After that, we know the derivative of a constant number will be 0. It means this term will be 0. And here we have minus 2, yes? It will be 2 multiplied by the derivative of this binomial will be 1 divided by x minus 5 squared. Okay, this is the first derivative. And the second derivative, what will be? We need to take the derivative of this function. Here, we use quotient rule again. 2 prime multiplied by x minus 5 squared minus 2 multiplied by x minus 5 square prime divided by x minus 5 to the 4 power, yes? Okay, then this expression will be 0 because the derivative of the constant number will be 0. After that, we need to take the derivative of this binomial, x minus 5 squared. What will be here, the derivative? I just write here x minus 5 square prime. It will be equal to, we use here chain rule, and I just write here, this will be equal to 2 multiplied by x minus 5. Okay, and if we put instead of this, here we have minus 2 multiplied by 2 multiplied by x minus 5 divided by x minus 5 to the 4 power. After that, if we multiply minus 2 by 2, it will be minus 4. Multiplying by x minus 5 divided by x minus 5 to the 4 power. And here we can simplify. It will be minus 4 divided by x minus 5 to the third power. Okay. After that, sixth step, increasing, decreasing intervals, extreme points. And to find these intervals, we use the first derivative, yes? And we know that the first derivative is equal to this expression, yes? 2 divided by x minus 5 squared. And I just write here, f prime x is equal to 2 divided by x minus 5 squared. And to find increasing and decreasing intervals, look, um, if you remember the definition or how to find increasing and decreasing intervals, they're written like this: f prime x, if f prime x is greater than 0, our function will be increasing. And if f prime x is less than 0, it will be decreasing. Okay, and look, if you look to this expression, in numerator we have the number 2, and in denominator we have this expression, x minus 2 squared. What does it mean? X minus 2, if you put instead of x any number, and subtract 5 and take the square, this will be always positive number. It means we just divide positive number by positive number. Yes, from that we can say this rational, this fraction will be always positive number. And we can say that our derivative, the first derivative, will be always positive. It means our function, our graph, always increasing. Okay, we don't have interval where our function is decreasing. Okay, next, concavity and inflection points. To find this, we use second derivative. Uh, we know that second derivative is equal to this expression, minus 4 divided by x minus 4 divided by x minus 5 cubed, f of f prime prime x. And to find concavity, where our function is concave up or down, uh, we construct the sign chart, yes? And we know that x is not equal to 5, yes, from the domain of the function. And look, from the right side, if you put any number that we have from the right side of this number, 5, for example, let me put 6, yes, instead of x. F prime prime 6 is equal to minus 4 divided by 6 minus 5 cubed. And what will be this number? 6 minus 5 is equal to 1. 1 cubed is 1. And if we divide minus 4 by 1, here will be minus 4. Minus 4 is a negative number. From that, from the right side of our assigned chart, we just put the sign minus. And here, let me check. Let me put the number from the left side of number 5. F prime prime 4 will be equal to minus 4 divided by 4 minus 5 cubed. And here we have minus 4 divided by minus 1. And if we divide them, we have the number 4. Number 4 is a positive number. From that, we just put here the sign plus. Okay? And where we have the sign plus, we know in this interval, our graph is concave up. And where we have sign minus, our graph is concave down. Okay? After that, we need to sketch our graph. Okay, to sketch the graph, firstly we need to draw a coordinate plane. This one is y-axis, and here we have x-axis. To sketch the graph, we use our informations, yes, that we done. First, a look at our asymptotes, where we have, okay, here we have asymptotes. Vertical asymptote, x is equal to 5, and y is equal to 0 is horizontal asymptote. Let me draw here by red pencil. Okay. Vertical asymptote is equal to x is equal to 5. And the horizontal asymptote is y is equal to 0. Okay, and these red and blue lines are our asymptotes. Asymptote means our graph is not intersect to these lines. Okay. After that, mm, let's look to intercepts. We just said we don't have x-intercept. It means our graph is not intersecting x-axis. And we have here y-intercept, yes? When x is equal to 0, y is equal to 2 over 5. Let's find this point, 0 and the 2 over 5. 0 and 2 over 5. If we divide this interval to 5 parts, 2 over 5 will be here. Okay, this will be our y-intercept, this point. Okay, next, we know that from minus infinity to 5, our graph is concave up. And from 5 to plus infinity, our graph is concave down. Let me give any point, okay, any point that we have from 0 to 5. For example, if we give 4 to our function, okay, to our function, f of 4 will be equal to minus 2 divided by 4 minus 5. And what will be? Minus 2 divided by minus 1 will be equal to 2, yes? It means that when x is equal to 4, our y is equal to 2. I just find second point. Let me give here number 3, yes? F of 3, let's find 3. Minus 2 divided by 3 minus 5, it will be equal to 1, yes? Minus 2 divided by minus 2 will be 1. When we give to x number 3, our y is equal to 1. Okay, and look, we have here 3 points, yes? 3 points. And we know on this interval, our graph is concave up. And I just draw here graph like this, concave up. And this goes upwards infinitely. Okay, and after that, let me give points that we have from the right side of the number 5. Let me give f of 6. What will be f of 6? F of 6 is equal to minus 2 divided by 6 minus 5. It will be equal to minus 2. When we give to x 6, our y is equal to minus 2. Okay, it's the first point. And let's find when we give to x number 7. Minus 2 divided by 7 minus 5 will be equal to minus 2 divided by 2 is minus 1. When we give to x7, our y is equal to minus 1. And look, we know that on this interval from 5 to plus infinity, our function, our graph is concave down, yes? It means we need to draw like this. Okay? And by using our informations, by following the steps, we just sketched our graph of our given function. Okay, that's all. Look, you can write these steps or you can take a screenshot. You'll use this information to sketch the graph of any function. Okay, have a nice day. Goodbye.